Hello, everyone. Thanks for joining us to the stream today. I'm Sanath. I'm a software engineer on the AWS Serverless team, primarily focusing on building SAM, which is Serverless Application Model, SAM's local CLI, and everything to improve the experience of developers building serverless applications. And I have with me Haider.
Hey everyone, Haider Lessa. I'm a specialist solutions architect working with serverless predominantly. And thanks for having me, Sanath, by the way.
Oh, you are a rock star on Twitter, so I need to have you here, man.
Very kind.
Yeah, so today what we're going to do is talk about building serverless applications. And we're going to talk about that in the context of using SAM, which is Serverless Application Model, to help you simplify the whole process of building serverless applications. So Haider, why don't you talk about your experience with building serverless applications and how SAM and the whole toolchain can help simplify this process for you?
Sure, absolutely. If anyone on this stream has used infrastructure as code or CloudFormation, you are definitely missing out on SAM. If you think about a CloudFormation template that could be 100 lines or so, in SAM, that application that you model, how do you call the Lambda function? How do you invoke the Lambda function? Through an API, through an S3 bucket, or something. SAM actually simplifies the experience a lot. SAM actually allows you to build. My day-to-day basis is mostly around web applications, some financial services. You think about a cron job or policy engines, or even actually Alexa bots. There's actually some cool stuff with Alexa saying these days.
I'm not quite sure how to help you with that.
Yeah, so...
Oh.
There's a lot of cool stuff you can do with SAM, and the way I think about build SAM is on a weekend I have this idea to build a serverless application, and I know what I want to build. I know how the end product has to look. I want a web service backend, and so I start out with a SAM template, kind of describing what these resources would be. And then start using the toolchain, which is SAM local CLI, to build and test my application SAM apps locally, and then deploy and test it on the cloud as well. So it kind of helps me with the entire flow. And once I'm done with it, satisfied, and I play with it for a few weeks, I tweak it and deploy it I publish it to the Serverless Application repository. Which is a great place for me to share my applications that I've built with other people and also kind of consume other people's applications.
You actually said something interesting, which is super cool from SAM. So you define your serverless application, how it should be, how it should look like, how it should invoke. You actually use SAM local to read your SAM template, invoke the Lambda function, set up API gateway locally, and once you're done with it, you can not only deploy that SAM application using the SAM CLI or AWS CLI, but also you can use this very same process that you've gone through to actually publish the application to Serverless Application Repository. And now everyone can discover that. It's actually,
exactly.
It's super cool.
Exactly. It's a lot of fun. And I think there's more there's more episodes on Twitch that somebody did a while back on how to publish to Serverless Application Repository. That's definitely recommended to check it out. But today, we're going to talk about SAM. Cool.
Right.
If I can switch to my screen here.
Cool.
Yeah, so SAM is open source. We've recently so SAM has been an open spec since 2016, which has had a lot of community participation on GitHub, proposing new features, finding bugs, helping to work with us to improve the SAM experience altogether. And in April, we open sourced the underlying implementation. What that means, I'm going to talk about it in a bit, but the code is here on GitHub. It's a standard Python module. And today we're going to talk about what this code does, how to use this code, and how to actually integrate the SAM translator into your existing infrastructure, which makes it for a super cool experience if you're building those applications.
When you say open source SAM, you mean actually the SAM translator folder that I'm seeing on your screen right now?
Yep, exactly.
Okay. And when you say SAM translator, is that that SAM will translate a SAM template into a standard CloudFormation template.
Yeah, so let me explain what I mean by that a little bit.
Cool. Okay.
So SAM is an abstraction on top of CloudFormation. If you guys are already familiar with CloudFormation, CloudFormation is lets you write infrastructure as a configuration file. So you can write a simple YAML or a JSON config file to define the resources in your application. So let's say I'm building an API backend. What do I need? I need a Lambda function. I need an API endpoint. I probably need a DynamoDB table and other things. And so in CloudFormation, you can define all of the resources you need in your application in a simple YAML or JSON file. And SAM is a flavor of CloudFormation or abstraction on top of CloudFormation geared specifically towards serverless. So there are new resources which are prefix which have the type AWS serverless blah. And we have 3 different resources in SAM. It's a function, API, and simple table. This might look small compared to hundreds of resources in CloudFormation, but when you think about SAM, it is a higher level abstraction. So there's a lot of logic that's happening behind the scenes that generates these CloudFormation resources for you. So you write just a few lines of SAM template.
Okay. So if I got that right, just to stop you for a second, because I've also been having some interesting questions. So the difference between SAM and other frameworks is that SAM actually works with standard CloudFormation resources, which means you can use this AWS column serverless instead of AWS column Lambda, but that doesn't mean you cannot have normal CloudFormation resources like an KMS key or something else.
Exactly. So that's one of the cool things about SAM is for the serverless pieces of your application, you can use SAM to define those resources. And if you want an Elasticsearch cluster, for example, you can fall back to the CloudFormation resource types. And so you're not only limited to what SAM provides. Think of it as a superset. That's how I think of it. So you have more resources than just CloudFormation offers. And we've had customers that use SAM just for their serverless pieces and extend that to include other resources.
Gotcha.
Yep. So if the template I have on the screen on the left-hand side is a SAM resource. So this is the AWS Serverless Function resource. It has certain properties in it, and the properties might look familiar to you. There's a Lambda function handler. There's the runtime that you want from a function, and there's a code where this function's code lives, right? And then there's a new section called events. I'm going to talk about this in a second, but what the rest of the properties do is it configures your Lambda function, right? Which is pretty obvious from the type name, so it's serverless. Yeah. The event section is interesting. So the way to think about Lambda is it helps you build an event-driven architecture. So Lambda function as such is just your compute portion, right? What if you want to include an S3 bucket? So a use case, a very common use case is, what if I want to thumbnail images that are being dropped by somebody or some other service into an S3 bucket, right? So you can connect a bucket to a Lambda function via an event, and behind the scenes, when an image is dropped into the bucket, there will be something that calls the Lambda function, and your function will run. And so in here, I have an event of type API. Gotcha. API is behind the scenes generates an API gateway resource, and so if you can see on the right here, I have my API gateway, REST API stage deployment. These are CloudFormation resources on the right that get generated.
I was going to ask that.
Exactly. So on the left, I have a SAM resource, which is about 10 lines. On the right, I have about 7 different CloudFormation resources that get created. So to be more specific, there's a bunch of API gateway resources to configure your API endpoint. And then there's the Lambda function. There's the IAM execution role to give your function. This gives permission for your function to call out to other services. And then there's a Lambda permission resource here, which gives API gateway the ability to invoke the Lambda function. So this is all being created for you by SAM.
Interesting. So if I could recap that a little bit, is only those lines in SAM would actually be converted into multiple CloudFormation resources. That could be multiple lines. And SAM not only takes care of actually looking at my local folder, my relative path, to actually depackage that code of mine and deploy that. But also, it takes care of actually setting up the permission between the resources that will invoke my Lambda function. And so I don't have to even think about this. All I'm thinking now, looking at your code sample, is this is where my function should look like. This is how my function should be invoked. And then SAM will take care of pretty much everything else.
Exactly. And we did this,
Gotcha.
If you think about it, this is powerful because the more you can offload permissions and other resources to SAM, what we do behind the scenes is create the minimum amount of permissions you need for your application to run, which means there's only in this SAM template, for example, your Lambda gets permission to be invoked only by this API and for the specific method in the stage. So there's minimal permissions that this function has, which means it's secure by default.
Perfect. Okay, got that.
And so once you have a SAM template, so you have the idea, and you've written the SAM template kind of to define the resources you need for your application. In this case, I'm building an API. And how do you deploy this? What do you do? What does the life cycle look like? So what I usually do is I write my SAM template. I like YAML. A lot of people like JSON. It works with both.
Yeah, I prefer YAML. I just don't like the indentation sometimes, but yeah.
Yeah, sometimes the indentations can be painful. If you have an editor that can show you the indentations with like dots or tabs, then it's a little more convenient that way.
Yeah, if you're using VI, the best IDE, so you should be fine, right?
Oh, you're a VI guy like me.
Okay, let's carry on.
So you have the SAM template, and then you can use SAM local. So what is SAM local? It is another open source project. It is a CLI tool that we have built that can let you run Lambda functions locally. What does this mean, and why do you need? Now you've built your SAM template, right? And then you have your code that you've written. You need some way of testing this before pushing it onto the cloud. And so you can use the SAM local CLI. You can go install it here, and then you can use a couple of commands called SAM local invoke. This will help you run the Lambda function locally. It knows how to read a SAM file, figure out where your code is, wire up the right container for the runtime that you need, and run the code locally. And then you can use the SAM package and deploy command to deploy to the cloud. And so the workflow that I usually follow is just write the template, write some hello world code, just to make sure kind of everything is wired up. Use SAM local to keep iterating and start building my code, and then I deploy it and iterate on there a little bit more. Okay. So it's kind of like test-driven development if you think about it. Like my local invoke is like my unit test. So I keep writing my unit test. I keep running it all the time, and my package and deploy to a personal stack is kind of my integration test. And once everything is cool, I then deploy to a production stack. In my case, if it's just a hobby project, it's just going to be just a different stack in my same account. But I make sure I have a dev stack that I use for tying with things, and a production stack that I don't touch, and I can pay more attention to it.
I think it's cool to mention that SAM package and SAM deploy, it's perfect from a CI/CD perspective because you can separate packaging from deployment. Permissions are going to be different. And all of this can run in a code build environment for a CI/CD or a Jenkins. So you can script that piece of packaging that up, deploying, and see if that deploy has been validated or not.
Yeah, the package, all it does is it takes in your local artifacts, which is a local code, and uploads to S3, and spits out a SAM template where, if I go back to here, where the code URI is not a local folder anymore. After you package, the code URI will be an S3 location. Because that's what the service CloudFormation can understand, and so it's excellent to split it out for your CI/CD pipeline where you package once, and that's your authoritative template that you keep promoting through your pipeline to different stages.
Right. Okay.
Cool. Now, I think I'm gonna switch hats. We've been using SAM.
That's fancy.
Yeah.
I'm missing one actually.
You need a hat for sure, Hader. Next time.
Oh man, next time.
Yeah. So we've been talking about how to use SAM, right? We've been talking about how to build a SAM app, how to use SAM local to test it locally, how to use package and deploy to the cloud. Now I want to switch gears and talk about how SAM works internally behind the scenes.
Oh, that's interesting. That's what I believe most of people are interested in now.
Exactly.
Let's get started.
Yeah. I wanna switch from being a user of SAM to being a builder of SAM itself. So there are three components in the SAM architecture. So before I talk about that, let's talk a little bit about where this code lives, where you can browse this code around, what sort of architecture this code has. So let me go back to the serverless application model, GitHub repo, and as Hater pointed out a little bit back, the SAM translator folder is where the code for the SAM implementation lives. We call this a SAM translator because if you think about how this works behind the scenes, there's a SAM template, and then there's CloudFormation service which creates your resources and your stack, right? There's something in between that converts your SAM template to a CloudFormation template, and that is happening transparently without your knowledge when you do SAM deploy. And the CloudFormation template is what gets deployed by the CloudFormation service. So it is just a transparent converter, and we call this a translator.
Gotcha.
And this is a standard Python package. It's got a bunch of code in it, but the most interesting one, I would say, if you are just browsing around, is to look at the translator package. So the transform function here is the starting point for the translator. What this does, it takes in a input SAM template. It has a couple of other parameters which you can ignore now. It constructs a parser. So a parser just takes in a SAM template and converts it to Python objects. So it just reads the template, parses it, does a lot of validation on top of it, make sure the required properties are set, make sure all the logical dependencies are wired up correctly. And then it calls the translator.translate method on the input template. The translator is the second phase, which takes in the Python objects and spits and reads the properties, converts it, spits out CloudFormation.
Okay. So those, just to make sure I understood that, so the parameter values are parameter actually that was passed with the CloudFormation, or is that a different parameter?
Yeah.
I was just not sure about that.
It is CloudFormation parameters. So think a SAM template is a CloudFormation template. It supports all properties that CloudFormation supports, like including parameters, including outputs. So you can just write a CloudFormation template just like how you would write otherwise, and include new resources, which are SAM resources. What the parameter values here does is it takes in values for your input parameters that can be resolved during the translation phase. So let's say you said my API needs to be the path to the API comes from a parameter. Then if you provide the parameter value in here, then SAM will know how to resolve that parameter value and set up the API correctly.
Okay.
So SAM kind of runs before CloudFormation engine actually executes to create the stack. So it doesn't hook into CloudFormation's like parameter processing or anything. So that's why SAM has its own kind of parameter parsing.
Okay.
Exactly. The managed policy loader is just an implementation detail, which what SAM also does behind the scenes is it has shortcuts for specifying policies. So instead of actually specifying an entire policy, you can just provide the name of the managed policy you want, and SAM will expand it to the R of the managed policy. So the loader just gives the translation between the name of the policy and the R. So this is kind of the high level of just the two components. And the third one we have is called plugins. These are plugins in the sense of this is a pluggable library that kind of wraps the core of the SAM translator itself. These are not plugins that you can pip install. So there's a distinction. You can call them as libraries or modules, if you will. We chose to use the word plugins in the translator. But cool. So what I'm going to do now, and this is the reason why I didn't full screen the PowerPoint presentation is I'm actually going to start drawing the SAM architecture here. So whenever I think about the SAM translator, I keep thinking about this black box.
All right.
My SAM template goes into a black box, which is my CloudFormation service, which is run when I type SAM deploy, CloudFormation gets called, and then it spits out CloudFormation, which gets deployed, right? So now this is my black box, and here's where my my SAM translator runs.
Okay.
Right? And so I'm going to start expanding what the translator is, so people can get a better idea of what it means. And I decided to do this instead of actually like showing a fully made presentation, because it's more interactive, and you can ask questions, and we can kind of take it in the direction that it needs to be rather than a set direction. So let's do this.
All right.
There's a parser, and then there's a translator. So I'm just going to kind of fill in the CloudFormation box here so people can see what's happening. Let's go add an arrow.
In the meantime, for those of you in the chat asking about the Lambda Builder hat, I think we should take orders. So a lot of people are asking where can they buy this?
Oh yeah, see, Builder hat is cool. I wish I can just wear it every day at work. Sweet. So here's kind of an expansion of the higher level view, which is there's a parser which takes in the SAM template, and then there's a translator which spits out CloudFormation.
Right.
And if you think about plugins, for example, they kind of fit in here.
Yeah, I was about to ask that question because you told us about the before and after. Okay, so that happens in between.
Yep.
Okay.
So plugins kind of live in between the different phases, and so a really cool implementation of plugin is the one I really like about is globals. So if you've used this feature in SAM, wherein I'm going to talk about globals a little bit because it's pretty cool. Let me go to an example. So in a SAM template, you don't have to specify all the properties all the time in your resources. If you have common properties, like for example, your API needs a core setting, and your API in general is going to have the same core settings no matter what API path you call into. So you can hoist those common properties up into a global structure, which we call globals. So globals does not add new features to SAM, as in it doesn't change what gets outputted in CloudFormation. It only makes it more easy for you to write a SAM template. So we decided to implement globals outside of the core translator, which is implemented as a plugin that runs before the parser runs. So the globals plugin, actually runs here before the parser runs. It reads the SAM template, looks at the global section, and injects the properties into every one of those resources. And so the whole parser and the translator doesn't even know about the existence of globals. It's kind of a pre-processing on top of your regular structure.
Interesting. So let me ask a question then. If I got this right, let's say I want to make a contribution to enable API keys authorization in API Gateway. And I would like to actually run that for every method I have. So that I can run that in books and simplify my template. I would actually make a contribution into the globals for the plugin, right?
No. So globals actually comes for free. So think about it this way. If API key is a property of an API resource, right? So you define your API resource and you want to add a property called API key, which has some values. That would be implemented inside the translator because it changes the output that you generate, right?
Oh, gotcha. Okay,
and then any property you add to the translator will be available for free inside the globals. So you don't have to do additional work to make it available in globals. That's how the plugin's built. But the way I would think about it is if you are adding a feature which is going to change what the CloudFormation output is, then it needs to be inside the core translator. If not, if it's just a syntactic sugar on top of your SAM template, it should be as a plugin.
Okay, understood.
Cool. So this is kind of like the high level architecture, the way I would think about it. But let's just actually dive into some code. We've open sourced this last April, and since then there's been a lot of like activity on GitHub with a lot of people sending us pull requests for features. This is excellent because we love getting community contribution, community participation in here. This is one of the things that keep us going. is the passion, right?
Yeah.
Yeah. So you talked about API key feature for an API. This person implemented server-side encryption support for simple table. So my DynamoDB table has a simplification in SAM called simple table, which kind of abstracts out all the complexities of setting up a DynamoDB table, specifically for your serverless resources. And this person added a server-side encryption support for it. But I'm not going to go through the commit and whatnot, but if you look at the whole process, you send out a pull request for a feature. So the way usually I would start with contribution is I'd first search in the issues to see if there's something that's already in the works, because you don't want to repeat yourself. You can work on something more important if somebody else is already working on it, right? I would search in issues to see if somebody else is already working on it. If not, if there's no issue for this feature that you want, cut an issue so we can track that you're actually working on it and other people will know about it, and then then make a change and send us a pull request. We have a Slack channel where our SAM developers hang out. So this is where all of us hang out here. So you can come in there, ask us questions. You will have a lot of passionate Python developers and serverless developers hanging out there. So yay!
Python, right? Python for the win.
Yeah. So it's actually a fun place to collaborate. I've learned a lot just by collaborating with people on the Slack channel. So come and ask us questions there. We'll help you out because we want you to be successful and not be more productive. That's what I mean.
Yeah. So that pull request you were showing to us, that looks interesting because I could see some comments by Jacob and also a few other people in there. And I think it feels like this is a really good start for people to see as an example on how to contribute. Yeah. And if I actually took a notice of the first comment of that pull request, it was the first contribution of that person, which is fantastic, actually.
Yeah, this is awesome.
Yeah.
This is the first contribution. GitHub even says it's a first-time contributor, which is super cool.
That's super awesome. Okay.
It's fantastic. And like as a first-time contributor, like the way I think of pull requests and comments on pull requests is you might see all of us get super passionate about the code, super nitpicky about naming conventions, spacings and whatnot. Yeah, you've been through the drill, right? So we get super nitpicky, and there could be a lot of back and forth and conversations. But one thing to always keep in mind on GitHub is we are criticizing your code. And not you. And that's something that a lot of people get it wrong when they start with open source. It's like, I sent out a really small pull request and this whole team was just on me, asking me why this and that. No, it's not you. It's just we make you as an owner of your pull request, and so we just ask you questions. But it's morely asking about the code and thinking out aloud. So if the pull request is not accepted, don't worry. Right from the start, it's just it's just a process.
Yeah, cool. And how I can see the pull request, but how do I get started? I know usually open source would have a developer guide or contribution guide or of some sort.
Exactly. So there's a contribution guide that we have. You can read through it. Kind of talks about what SAM is, how to integrate SAM with other tool chains, like just a high level of what you can do. And then there is a development guide, which is more specific. It talks about how to install different Python versions, how to install dependencies, and set up pull requests and stuff like that. So I am actually, going to write a feature now on SAM to kind of demonstrate how this works from perspective of somebody that's gotten that wants to write a new feature that has an itch that they want to scratch. Cool. All right. So people have been asking about this feature for adding tags to API gateway resources. So in SAM, we have the Serverless API resource, and it doesn't support tags yet. So there's been a feature request for this on GitHub. So I'm going to add tags to my APIs. That's what I'm going to do.
Oh, so hang on. Does that mean we're going to fix that issue live?
Yeah, exactly.
All right. That's pretty cool. Just give me a second.
Yeah, we're going to fix this issue live. This person also kind of explained how the input SAM template and the output CloudFormation template is going to look like. So It's awesome because all I need is this, right? So in my Serverless API resource, I'm going to add a new property called tags, which is going to take a key value of the tags that I want to set on the resource, which is eventually going to get injected onto the stage resource. So I don't want to go through the entire process right now, as in I don't want to be super fast and kind of show you the magic of how this all works in 2 seconds, but I want to take it slow. So we might not get to actually finishing the feature on the stream today, but the goal is to kind of explain how the code is laid out, where to get started, what are the first commands you run, to kind of orient yourself where you are, and we'll see how far along we can get along with this code. All right?
Mm-hmm. Perfect. Okay, let's go.
Sounds good. So, terminal. I have my code that I've checked out from my Git repo. So I'm sure all of you know how to check out clone something from Git. So I have my code that's already cloned, and I followed the development guide to set up a virtual environment. So if you guys are from the Node.js land, virtual env, think of it as your node modules. This is just gives you a virtual environment for you to install new modules in it, and each project can have its own virtual env if you want. It just gives you a clean slate to start with. So I know how to set up a virtual env here, and I've used Python 2.7. And to first get started, just type make. If you're on a Mac, which I am, you should usually have a make command that's installed, or you can install make, the GNU make on any machine. It's usually available.
Yeah.
So if you type make...
If you are on Windows, just in case, you can have git bash, which I'm sure you have git, right? And then git bash has make as well.
Right. So make is a very popular command, and it's fairly easy to get make set up on your computer. And once you have make, you kind of have everything else. So just type make, and it gives you all the commands for you to get started. And so the install and setup is for installation, just getting a virtual env set up. And then I've activated my virtual env. Now I'm going to do make init, which is going to install all the requirements. This is just installing all the dependencies on my virtual env, and then run make test. So talking about testing, this is one of the things that you will hear us talk about a lot on the GitHub pull request is tests, writing tests, and
why not, right?
Not even why not. It's like you have to write tests.
Actually, if you think about it, what could possibly go wrong without tests, right? I mean,
yeah, we all live on the edge. No, I don't. I get super paranoid if I don't write tests. It's one of those things that I cannot live without. And the whole team is just very picky about getting good coverage of tests. If you write code that reduces the test coverage below 95%, the command will fail, and so your pull request will not be accepted. So you can't even push it out. And so
nice.
I usually do make tests. So just to make sure a sanity check of everything working end to end, we're good. And then let's jump into the code. So to just give you some whereabouts of where we are, I have the code checked out, and I'm in the SAM translator folder, and I'm looking at.
Sanav, quick, sorry, can you actually zoom in on to see your folders on the left?
I don't know how to do that.
I don't know if you can do this. So usually in Mac, you would do a command option in 8, but otherwise that's fine. we can carry on with this.
Yeah, let me show you. Let me show this location on GitHub, so it's kind of much more intuitive. So I'm inside SAM translator. This is all the folders. This is where all the folders are. Excuse me. And then there is a model folder, which defines the SAM model, which is all the resources in your SAM template. And so we have the event sources here, which define the events. We talked about API. We have a bunch of other events like S3, SNS, and others. And we have a bunch of resources in here. If I scroll down, there's a file called SAM resources. Obviously, this is where all my SAM resources get defined, right?
Cool.
So if I look at a SAM resource, I have a SAM function resource, which is my serverless function, and here's all the properties we saw a few minutes back, right? My handler, runtime, code URI, and all that stuff. So this structure kind of just defines the validation logic for my resource. So my runtime needs to be a string. Obviously, it can't be a dictionary, right? And then we define all the properties here. And if you scroll further down, there is a toCloudFormation method in here. I think I went past it.
No problem. We're gonna find it.
Yeah. Yep. So there's a toCloudFormation method in here. So the way we define all the SAM resources, every one of those SAM resources have a toCloudFormation method in here. And so when the translator runs, going back to our mental map of the parser and the translator, right? So when the parser runs, it converts a SAM template to Python objects. And this is the Python object that I was referring to, the SAM function class. That has a toCloudFormation method. And in the translator, all it does is calls toCloudFormation on every one of those Python objects, which spits out a bunch of CloudFormation resources that gets upgraded. That's kind of the high level of how this works.
Makes sense to me.
Going back to my code, I'm going to look at my SAM API resource. This is the resource that I want to add a new feature to, and I want to add a tags property to it. So my property type tags is not required, and it could be a type dictionary. So again, add a lot of comments to explain what tags is. Adding tags.
And that's going to be a dictionary because you can have multiple tags.
Yep. Tags are a key value of tag name and tag value. You can have multiple tags, and you need to make sure. One of the things that we try to do always inside a Python code base in general is add as many comments as you want, because sometimes it's not obvious what a code does by just reading it, and comments will kind of give you the clue to understand more context instead of actually browsing through the caller and the caller. You can understand more context with comments. So comments plus ones.
So let me be very nitty-picky. So I was looking at the cores, and it looks like it's a single quote, and then tags is double quotes.
Yep.
Maybe Jacob will actually make a comment on the PR and say that's not good enough, right, Jacob? I know Jacob is on the chat.
Yeah, Jacob's usually nitpicky on these things. I know. Sometimes I just send out a PR and I'm like, please get it approved, and then Jacob will be like, comment 1, comment 2, comment 3. It's like,
Right.
But
okay.
This is good. So consistency is important. It also calls out another point. Like usually these sort of things are kind of contextual. So if you look at a region of code and you see a certain pattern that is being used there, try to follow the same pattern over. So it looks nice, and then later people don't think about why is it different, right? So that helps that.
Right.
Cool. So there's some magic that happens on the base classes that gives you a property called tags on this object by just defining a tags here. And we already have a separate method that can support tags, which is just a common implementation for how tags have to work in the serverless function, serverless API, and everywhere inside SAM. So all I'm going to do is I'm going to use this method here, I'm going to say tags list and pass it the tags that I want.
Right. Isn't that self.get tags list? I think it's the same. Let's say.
Let's see. Oh, it's get tag list.
Okay, cool. It's not under the class. Okay.
Yeah, it's not in the class.
All right.
So now I've gotten the tags that I need to pass it out to CloudFormation. And I'm going to pass it to the API generator, which is just a wrapper that is going to generate all the API gateway specific resources. I'm going to say tags. Now, I've added something to my class. I need to go add a new property to the class called tags.
Okay. Sanav, let me stop you right there. Yes, I was about to ask you, can you increase the size of the text?
Yep.
But cool. And of course, add some doc strings.
For sure. Doc strings are super important. And so now we've made the tags property kind of available onto the API generator. This class is solely responsible for reading your API configuration and generating the CloudFormation resources. So this will construct a REST API resource, which is just a CloudFormation resource for API gateway. It's going to set up regional endpoints if you need. It's going to add cores. It knows how to read your Swagger Open API definitions and pass it down to CloudFormation. It does all that stuff here. And somewhere in here, which there's a section that says construct stage. Now, the question that somebody might ask is, how do I know where to inject the tags property to, right? So translating that, the question is, how do I know what the CloudFormation output should look like? This goes back to the GitHub issue that I was talking about. When you cut a new issue or when you start working on a feature, the first thing to do is explain how your SAM template is going to look like and how your transform CloudFormation template is going to look like. So gotcha. I don't even know how, because this person wrote it, I kind of assume that this is going to be right. I would definitely go in and validate, actually write a CloudFormation template, deploy it via CloudFormation, and make sure that this property has to be in here. And that's the due diligence that has to happen behind the scenes before we get this out. Before you send a pull request first.
Yeah, and then it becomes a conversation, like exactly the same pull request we were showing earlier as well. It becomes a discussion about, is this the right approach? Is that helps with your use case? Yeah,
exactly.
Sure.
Exactly. So now I know that I need to inject the tags property to my API gateway stage resource, right?
Yep.
So let me go look at the code to where the stage is getting constructed. This is where we construct the stage resource. And so I am going to add tags to the stage. But I need to make sure that my stage can support tags, which means I will go into the API Gateway stage resource. So we have two sets of resources which are defined kind of similar. One is the SAM resources, which is Serverless Function, API, and Simple Table. The other set is the API Gateway resources, or CloudFormation resources. In this case, it's the API Gateway.
Right. So we can actually see, for those of you trying to follow, we can see that this is a CloudFormation resource. If you look at the line resource type, there's AWS column, API Gateway, and then stage. That, if it was SAM, that would be AWS column, serverless, and then API in that case.
Exactly. So we do this just to make sure the code that we generate out of the SAM template is compliant with the API Gateway syntax. So we don't want to just generate arbitrary dictionaries. We want to have proper validation on the dictionary itself before we generate the CloudFormation resource. This is why we have defined the resources, the CloudFormation resources also here as a way for us to implement this validation. And so I added the tags property to my stage resource. And now let me go back here. So my stage now can support tags. And so I'm assigning the tags value back to the stage. So this is pretty much what I need to support tags in API Gateway. Now, is this going to work?
Let's see. Maybe we need tests, or maybe we just try this out.
We absolutely need tests. So before you try it out, I would say just write the test, because that kind of reinforces the thinking that you need to have when building these applications is going back to our mental model of taking a SAM template, running it through a black box, and getting a CloudFormation output. This is exactly how our testing structure is also set up. So if I go back to my tests here on GitHub, there's a folder called tests, and there's the translator test, which has inputs. So these are SAM templates. If I open, let's say, an API with course, this is just a SAM template as an input. And so just remember the name API with course, right? There's a file in here for the input SAM template. And there's a file in here for an output CloudFormation template. We just use JSON for convenience. And it's still referred to the same name, called API with course. And this is just the CloudFormation expected output that we expect out of the resource.
Makes sense. Which kind of goes back to this issue that how that person would like to see it available as a feature, and how the CloudFormation output. That makes sense to me now.
Exactly. So that's why I wanted to go back to the higher level picture all the time. Is what is your SAM template? What is your CloudFormation template? Everything inside, everything in between the translator piece is a black box that we will hash out. And so if you keep going back to that thinking all the time, then it makes it very easy to build SAM itself, because all you need to think about is what my CloudFormation output is going to be.
Right. So the next step, if I got this right, then would be let's create a input under tests that would actually see a new tag being added to the API gateway resource.
Exactly.
And then the output we will see. Got you. All right.
Exactly. So let's do that right now. So what I'm going to do for now, I'm going to show you where the test file is. So under the test directory inside translator, there is a test translator file, and this is the file I've opened up here. So if I look at it, these are all the tests that we have. These are kind of the end-to-end functional tests that we have. So API with course is somewhere in here, and everything else. This is just the name of the file, input and output, and the test harness will know how to manipulate it. All right.
Okay.
So for starters, I wouldn't recommend writing your CloudFormation template by hand, because we already have a rich set of tests here. Let's start with something that we already know. Okay. So what I'm going to do is I'm just going to go through to my explicit API test, which is my AWS Serverless API test. And let me go to the test file and open up input. On translator, input.
And then input, yes.
Exactly. So I need... So
it would be called explicit API.
Correct. Explicit API.yaml. So this is a test that I have. It's a great starting point for us. So just to quickly kind of test that our implementation works, I'm going to modify the existing test just to make sure what we've written works. And then I'm going to add a whole new test for tags just specifically, so that the whole PR could be complete.
Right.
Let me go to my API, and we're adding tags, key value. Call it my key.
My value.
All right.
Mm-hmm.
And so this is the get HTML API. So I'm going to go to the corresponding explicit API.json file, which is in the translator/output directory, which is the expected CloudFormation output, right?
Mm-hmm.
And I'm going to go into the get HTML API resource, right? So the way the resources are named is if you have a SAM resource with the name, with the logical ID get HTML API, that's going to be the prefix of all the API gateway resources that we get generated. So in this case, the REST API is going to have a prefix get HTML API, and my stage here is also going to have the same prefix, but has a suffix of stage. So now I found the stage that I care about. Let me go add tags to it.
Right.
And so the tags in the SAM syntax is going to be different from the tags in the CloudFormation syntax. right? We kind of hand waved all of that because the implementation is already done. That can take in a SAM tag structure and convert it to a CloudFormation tag structure. So I didn't care to explain how this is going to work, but for the sake of test, we do have to write down how the structure is going to be. And for that, I will go back to my GitHub issue and refer to how the structure is on the output CloudFormation, which is why I keep going back to the SAM and CloudFormation pairs. I need a key with the key and a value with the value, and this is going to be an array. So my key.
That would be my key, and then value, my value.
Yep.
Right.
Cool. Now we've modified the explicit API test, right? And so if I run make test, it's going to go through this new code that we've written through the modified test, and I'm going to verify that everything works. Are you ready? This is very good.
I think we are.
All right, let's run make test.
Yeah. Cool.
Oh. Fun.
So the code was actually, let's see.
The problem is
non-defined argument.
Yep.
On the API generator.
I made a mistake on my thing here. So
here we go.
This is a good Python learning for those of you that are wanting to learn Python or already know Python. I don't know. Python allows keywords that are named and also unnamed. So these are positional arguments. You can pass values in the specific positions, and if you specify default values to any of these arguments, those don't need to be positional. You can say method settings equals blah as your value there, and if you already started writing your default values arguments, the one that is following it also needs to have a default value. So you can't mix keyword arguments with non-keyword arguments. That's why.
Right. So let's give that a try again. Let's see.
It's running.
Looking good though.
Let's see. The F's are failures.
But they might be expected failures. Let's see.
I don't know.
There's too many F's in there. I'm not liking it.
It's a lot of F's in there. So I think I made a general mistake that made most of my tests fail. So I'm gonna look at what it is.
Okay. So
let's see. Right? And the problem is a bunch of these call these out as invalid documents. So most of my templates are now called out as invalid documents, and my tags, it says my tags is not defined. All right, I kind of know what is going on. So when I define my tags here, I made it a default. I added tags by default, right? And I need to change this to add tags only when there is tags here, because I don't care about it otherwise. And I made a typo where the output tag
supposed to be capital T.
So if I go to my API Gateway stage resource, the tags
you
property.
have to change that. Yeah.
Yep, it's capital T.
I can see that.
And I used a small t in here. So
gotcha.
that explains why almost every one of those API tests failed.
And it makes sense the invalid document error exception as well.
Exactly. It complained because I was trying to generate an invalid CloudFormation template.
In the meantime, the test runs. I found something interesting though. When you were looking at the input and output for tests, when you look at the output, you could see the resource name and you append something like stage or role for Lambda functions. That is super interesting because we can see what resources will be created implicitly, and we can just use a ref, or we can capture that later. For instance, you can use this. Well, the documentation now reflects this, but I can use this to know what is my Lambda role actually name will look like, so I can reference that in a IAM policy or something else.
Yeah, absolutely. And SAM also provides a neat feature for you that you can get the names of the resource without actually constructing them by appending stuff to it. So if you go to the documentation, and let's look at internals, generated resources. So this is the documentation that's going to give you all the generated resources and how they're constructed. So it says, if my serverless function is named my function, and it's going to get a Lambda function, and an IAM role, which has a suffix role. So if I go back to my API gateway resource, it's going to generate a stage, and this is how the stage is generated, and it's going to generate a deployment. That's how it's deployment generated.
Perfect.
So this document gives you all that you need to construct these. And there's another way wherein you can say my API.stage will actually give you the stage, will give you the generated stage name automatically. So that's a SAM feature that we have built. I don't want to go into it now, but there's documentation and it'll explain.
Yeah, we have a few minutes left, so let's see how we are on it. So it looks like there's a small failure in there. What is it?
More invalid document exception. It's specifically coming from explicit API. Yep. So all of these. So now the good news is only the explicit API ones failed.
True.
The bad news is we don't know why. And this is where I would usually start my development is I write some code, I write some tests, I run it and see my test fail. And the chase is figuring out why it failed.
Right.
I don't want to go through that right now because we only have a few minutes. But I want to make sure I want to kind of capture that this is the process. And once you make your test pass, there's also another command called make PR that you run, which will run all the validation that we need end to end. And when make PR passes, you can push your code to a fork on GitHub, and then send us a pull request. And it goes back to the pull request process that I was talking about. So when you're stuck and when you don't know what to do, reach out to us on Slack channel, and that's where we're there to help you out, or actually even send a work in progress pull request. I actually learned from a recent podcast that a work in progress pull request is a thing. It's a thing. It is, yeah. I didn't know that. I was like, I'm too embarrassed to send out my shitty code out to people to waste their time. But I mean, sometimes if you're stuck for too long, it's okay to send a work in progress pull request so we can review it, give you feedback, and kind of at least help you move in the right direction.
Yeah, I think it's interesting to say that if you open up the make file very quickly, we can do it in a few seconds only. If you open up that make file, that PR actually will run PyTests and all these pieces that we actually need for a style perspective, and also make sure that we follow the same style, we follow the same structure, and some Python best practices as well.
Exactly. So this is just a one command that'll run all the time on our bull fleet. So just to make sure anything that we take in is of high quality is just automatically verified.
Yeah. What's also I think important to call out before we close is even if you actually are not yet familiar with the SAM code, etc., which is actually the purpose of actually having these episodes, we have yet a lot more to cover in future episodes. If you look actually one of the I just published on the chat. There was a PR that some Raphael actually made some enhancements to the setup.py. So the PR is actually 381. And actually any sort of a contribution actually helps. From documentation to setup.py, Raphael was actually telling us on Slack as well, as we were discussing, that there could be some enhancements the way this SAM translator gets installed and everything.
Yeah, definitely. Like, it's not only the new features that we add to SAM, but everything around it. We welcome contributions to documentation, setup, everything, including tests, refactor. There's even somebody that started off with Python 2 to 3 migration, which is awesome. So we totally, waiting for Python 3. So anything that you want to do with the SAM translator, we are here to support you there. And so feel free to hit us up on GitHub or Slack. The link to join the Slack channel is almost all the way down to the on the repo. So it's a good place to start. I think we're almost out of time.
Yeah, I think we are. I think just to make sure that people actually know what the next step is going to be. So next episode, we're going to make sure that new feature actually goes live.
Yes.
And then we cover perhaps more of how the intrinsic actually works behind under SAM, right?
Yep. So we just scratched the surface of the implementation. So we're going to go more deeper into specifics and probably even write a more involved feature.
Perfect. Okay. Well, for those of you who actually are on the stream, thank you so much for actually joining us today. We're definitely going to reach out when the next episode is going to be, but it's very, very soon, right? And for the hat, I think, Sanav, you're going to have a problem now. People know you're on Slack, and they're going to ask you to order some of those.
Oh my God, I need to get a bunch of these hats. I don't know if I can just live with one.
Perfect.
Cool. Thank you.
Thanks for having me, Sanav, and thank you everyone for joining.
Thank you, everyone.
Bye-bye. See you on Slack.